Okay, so today's podcast will deal with the use of a balanced equation to convert from the moles of one substance to the moles of another substance, something that we call mole-to-mole stoichiometry. So it's really pretty simple when you get down to it, because all you need to know are the numbers in the balanced equation, the coefficients that we put in front of each substance. So, for instance, I know that in this equation I have 4 moles of aluminum and 3 moles of oxygen that combine to form 2 moles of aluminum oxide. Now, you know that we're not going to make it that simple, and so here's the question that you might be asked. And this is typical of a question you might be asked about this sort of topic. How many moles of each reactant would we need to produce 14 moles of aluminum oxide? So we basically got 2 separate calculations here. First, we're going to be asked how many moles of aluminum do we need? And second, we're going to be asked how many moles of oxygen. So let's start with aluminum, since it's the first one we see. So in every case, in all of these problems, you want to start with what you know. So I'm going to go ahead and make a grid, just like we have in class. I'm abbreviating moles, MOL, which is totally acceptable. And I'm going to make a grid. Now, as we talked about in class with dimensional analysis, or the factor label method, the key here is to make sure we're canceling out units by putting the same thing on the bottom here as we do on the top. So we need to make sure they match up diagonally. So if we start with moles of aluminum oxide, we're going to want to have moles of aluminum oxide on the bottom in our next step. So to figure out the moles of aluminum oxide, all you have to do is look at the balanced equation and look at the coefficient that is in that equation. So in this case, that coefficient is 2. So I'm going to go ahead and fill in 2 moles of aluminum oxide on the bottom. Now the question asks us, the first part of the question at least, asks us about aluminum. So we're going to want to look back at that equation, and we're going to want to figure out how many moles of aluminum there are in the equation. So, as you can see, there are 4, because there's a coefficient of 4. So I'll fill that in on the top. This is one of those easy green circle type one-step problems, so we're pretty much done. We'll go ahead and cross out those 2 units since they cancel. And we'll do the math. 14 times 4 gives us 56, and then we divide by 2 on the bottom, and we get 28 moles of aluminum. Now, you probably could have done that calculation in your head, but again, like I said in class, it's important to get used to using this method for when we get into some slightly harder problems, 2 and 3 steppers. So, next, we want to know how many moles of oxygen we're going to get. So we're going to start with the same 14 moles of aluminum oxide, because that's what we know from the problem. And this time, we're still going to put the 2 moles of aluminum oxide on the bottom, because that's still the same number of moles that we had in the equation. Go ahead and cross those out. And then, we need to know now about oxygen. So, we look back at the equation, we find out that there are 3 moles of oxygen in the equation from that coefficient in the balanced equation. And now we do our work. 14 times 3 gives us 42, then we divide by 2, and that gives us 21 moles of oxygen. So what we've been doing here, this part right here that I just circled, that is called a mole ratio. And that mole ratio is going to be the key to our study of stoichiometry. So, if we get used to it now, we're going to be much better off in the future. Thanks for watching.